should start. Other people might join us. So how was the homework? Hard? Yeah, that's the thing. That's all there is to economics. It's well, you can just explain things in words, but the special thing about economics is we try to, in a sense, say the same thing with graphs, text, and computation, and somehow make sure that everything is coherent, so we know that we're not sort of cheating ourselves or lying to ourselves. And then, yeah, so a model that is done, say, in Canada is going to be more or less the same and pretty much understood by somebody in Japan or in anywhere. So that's the goal. All right. It's a good idea for me to know that for the final exam. So I'm not going to rely too much on the math because I know it's a bit far for you. Yeah, so I'll take it into account. I'll check how you guys did. And yeah, so just to tell you the program. So we're finishing chapter 6 perhaps today. We'll see how we go. And then I had prepared, so I want just to grade give you the solutions and go over them in class next time. And I had some, in my opinion, very interesting example with this chapter, but if the homework was difficult, maybe this example is going to be difficult a bit. So, but what I plan to do is maybe I'll go over it then again next time. And yeah, gravity probably not. So yeah, so I can tell you just in a nutshell what gravity equation is. It's just that, so you probably know, have heard about the gravity in physics. You know, there's gravity that makes my mask fall down, for instance. So we know that from Newton. So basically, how two bodies that have mass attract each other is a function of the mass of first body, mass of second body, and divided, so both multiplied, divided by the distance squared. And it's been realized that in economics, an extremely good predictor of trade flows between two countries is GDP of country 1 multiplied by GDP of country 2 divided by distance, or some sort of measure of distance. And the whole goal of this research program is to know what distance is. So physical distance, of course, matters. Distance is a sort of big basket that encompasses everything from how costly it is to export something to some other country, but also we realize that things like common language, colonial heritage. So if somebody has, if some country has colonized some other country in the past, and then that country becomes independent, then this disturbs trade flows. So, and of course, trade unions, treaties, WTO, all of these things do matter, and it's a way to quantify everything. So it's a very neat introduction to all of what is done empirically in trade theory. But I don't think I'm going to to get there, so that's why I'm just going to give you this small preview. Yeah, so this class we finish here, and then I'm hopefully going to be able to do chapter 6, and then exercises. And then it's case study number 1, then exam in 2 weeks, then case study number 2, then presentations. So next week, I'm going to tell you all about what I want in the case studies. You have done case studies in the past? No? Okay. Because this is something that the teacher before me did in class. And I thought, okay, I've never done that, but that's probably something that students in trade school or MBAs do. So they probably know more what they're doing. So if you don't, I might ask. Well, he told me what he did basically in class, but yeah, I'm going to ask more questions. Yeah, everybody's. It's like the blind leading the blind. All right, so let's get on with the class. So market structure. So this is what we did last time. I'm just going to remind everybody what we were doing. So perfect competition. What's up with perfect competition? So if there's a firm that has some profit, pi of Q, and of course the profit is revenue minus cost. And what matters is what revenue is. So in the case of perfect competition, it's simply the revenue is simply R of Q is P times Q. So price times quantity, and here the price doesn't change. So it's what we would call a perfectly elastic demand curve, because if I increase my price by 1 cent, then everybody stops buying from me. So I don't have any choice but to sell at the market price P, and I cannot change it essentially. And then what we find is essentially this very important relation that price must be equal to marginal cost. So the income I get from the last unit sold is its price, and it must be equal to what that last unit cost me, which is the marginal cost to produce it. Yeah, and this is the profit. Now we saw after that monopoly, which is, you would say, another extreme. So here perfect competition is with an infinite number of firms, and now monopoly is with a single firm on the market, and we see it's non-discriminating. So that's for what I would say a single price. So sometimes it's called a single price monopoly. It's a monopoly that has the burden of choosing, one, the quantity produced, but two, indirectly the price of the market, because it faces the whole demand, and the demand is negatively sloped. Yeah, so we have exactly the same problem, except that now instead of having R of Q is P times Q, it's P of Q, because the price goes down as Q increases. But otherwise we get the same sort of result, just that now we have this extra term there, which is the fact that when I increase the quantity sold, yes, I make more money in the last unit I sell, but I lose money from all the previous unit. I have to lower the cost of the price. Yeah, and then we had a small example, and we showed that if I choose, if I solve for the monopoly case, I get that the monopoly, so that, yeah, my price was where is my, oh yeah, that's my linear example. So the price is 13 minus Q, cost was 12 plus Q. Yeah, so if I do that, then I find that the monopoly will produce 6 and have a market price of 7. But if the monopoly acts as in perfect competition and chooses price equals marginal cost, then you see that quantity is 12 and price is 1. So quantity is much higher and price is much lower. So it's much better for consumers. So the interpretation, of course, is that so the monopolist has market power and is able to charge above the marginal cost. All right. So now, last layer on this theory is Cournot's oligopoly. So I was planning on doing just with 2 firms, but I think I'm going to do with 2 and then with 5, I think. So it gives you a neat way into seeing how the number of firms on the market affects price. So here we go. Yeah, so in Cournot oligopoly, we have many firms that sell a uniform product. And each firm assumes that the other firms will sell whatever they sell, and they choose their optimal quantity and their optimal quantity based on the remaining number of customers that they can still serve. Yeah, so let's start with example with two firms. So we would call this a duoplex. So we have Q1 and now Q2 are the production of firm 1 and firm 2. The total production in the market is simply the sum of the production of both firms, so Q1 plus Q2. And so let's go for it. So rather than doing a bunch of calculation, I think I'll go directly towards the example. It's going to be easier for everybody. So then what I have to assume is that if it's firm 1's problem, then firm 1's take firm 2's production, Q2, just as some given, something that's there and that it cannot change. And then it maximizes its own profit, taking Q2 as given, right? So firm 1 maximize as given. So back in our numerical example, so we had and then the only thing you change is that now you don't care about the quantity of the whole market because it's not a monopoly, it's just firm 1. So we're going to write Q1 and then profit of firm 1 as function of, but then it's function of the production of the two firms. Why? Because if the firm 2 produces more, then that takes away some market share for myself. So it's part of my profit function, but it's not something that I choose, it's just something that's there. And how it is? Well, here rather than have Q, I just have Q1 plus Q2. So that's going to be minus Q1 minus Q2. All right. And this is the market price. So the firm 1 obviously just has revenue from Q1 sales and has costs 12 plus Q1 because that's Q. So that's the whole thing that's changed. Does that make sense? All right. And so always write it this way, by which I mean after that, we can know a lot of things, we can simplify stuff, but before maximizing the profit, please write it this way. Otherwise, you're going to make a mistake. Like if you say something like, oh, let me substitute this by Q, then you're not going to, you have to distinguish what's produced by whom, so that when you take the derivatives, you get the right result. So write it this with what I think I'm saying. Okay. Maximizing. So I take the first derivative, and now I'm going to write it as partial derivative. just because I derive just with respect to the first argument. So if you're not too familiar with partial derivatives, it's just like normal derivative, but we use this curly special D because just to remind ourselves that we could be deriving with respect to many different arguments, not just one, but the idea is the same. Okay, so here I have Q1 in two places, just as before I had Q in two places. So if I take the derivative with respect to Q1 here, then I get this. And if I take the derivative with respect to Q1 here, I get -1 times, so this doesn't appear, this doesn't appear, but I have minus Q1. And then the derivative of 12 is 0, and the derivative of Q1 is 1. So I get -1. So it looks very much like the monopolist. It's just that the monopolist, I would have had Q here and Q here. Here, I still have Q, but essentially because I have Q1 minus Q2, so it's minus Q. But the difference really is this second term there, which would have been Q, but now it's just Q1. But the same is true. Okay, so this is what I get, and now I can start to think about the thing I could do with that. So, but essentially, I have two variables for which I need to find a result, not just Q1, but Q2 as well. So what I could do is do the same with Q2 for firm 2. So what would I get, do you think? I forgot my water bottle. If I did this exact same thing for firm 2. Well, the thing you have to look is to realize is, so you essentially you exchange 1 and 2 in this equation there. So you maximize the profit of firm 2, choosing Q2 and taking Q1 as given. And so what we would get as a result is 13 minus Q1 minus Q2 minus Q2 minus 1 equals 0. So it just, if I do the same for firm 2, so I get just that there's a Q2 here. But we don't even have to do that. Why don't we need to do that? Well, because so we have written the problem saying that, yeah, that's something with two, I should have said that. So two identical things. That's an important point I didn't say. Because yeah, if they were not identical, you really need to solve it for firm 1, solve it for firm 2. But if they are identical, then you know that if you do it for one, then if you do it for a second one, you should really get something that's the same as for firm 1. So whatever you do, in the end, you should find that all firms produce exactly the same, which is going to be an important point for when we see the monopolistic competition. So, but we can also, yeah, so just using this, we could use these two conditions with two variables, two equations, two variables. You solve for Q1 and Q2, that's easy. But we can also see that. is symmetric. We will get Q1 equals Q2. So using this, we can just pick the first condition. So for instance, this one. This is first order condition. So using first order condition for Fermat. So I can just write it this way. So I know that Q2 equals Q1, so I'm just going to replace by Q1. I get this. And then what do I get? I get 13 minus Q1 minus Q1 minus Q1, so minus 3 Q1 minus 1 equals 0. So let me just solve this very quickly. So that's that. 13 minus 1 is 12. Then I have minus 3 Q1. So I find that Q1 will be equals to 2. And how do I find the, oh yeah, so that's 4. So what would be equal Q2? 4 as well, because we have established that they are the same. So what would be equal Q? Yes, 4 plus 4, 8. And what would be equal the market price, P? P was, oh yeah, so P was equal to 13 minus, or 13 minus Q essentially. 13 minus 4 minus 4. So that's equal to, yes. So that's the market price, all right? So this is, yeah, and I don't want to go I could say a lot of more things about this, but it's not the point. The point is just to show how different number of firms affect competition. And just for the sake of it, let's try quickly with 5 firms. So here I'm just going to do it quickly. The goal is to show what happens when you vary the number of firms. So here let's have Q1. So Fermat's profit would be so here is a function of Q1, Q2, Q3, Q4, Q5. So it's minus Q1, minus Q2, minus Q3, minus Q4, minus Q5. So what's happening there? Well, the price is getting lower and lower and lower and lower. This is the market price, and you have and more and more and more and more competitors in the market. So firm one essentially has less and less space to apply its market power, but it's still going to do its best to have market power. So first order condition. So what we're going to get is, so I'm just going to write by one EQ1. So it's still a function of all these things. I'm just not going to write it because it's for space sake. If I take the derivative, so again, I have Q1 here and Q1 there. So it's always the same. My production decreases the price and my production increases my sales. So derivative with respect to the first, to this one, this Q1 is just this thing there. There's the price. And then I have, with respect to this Q1 here, is -1 multiplied by Q1, so minus Q1. And then this is the same, so 12 is nothing, -0, and there's with respect to Q1 is -1. And then same trick, so by symmetry. One equals of course, if they were not symmetrical, so if they had different costs, for instance, then you would need to do this operation for each firm and solve a 5 equation, 5 unknown problem. I'm not going to bother you with this sort of problem. We want to simply make our life simpler. So let's choose that all the firms are the same. And so what we get is 13 minus Q1 minus Q1 minus Q1 minus Q1 equals 0. And I get it. So that's 12. Minus 1 there. 1, 2, 3, 4, 5, 6 minus 6 Q1 equals 0. And I find that Q1 equals, so Q equals 6 Q1, 5 Q1. Because I have 5 firms, so it's equals to 10, and the price is 3 minus Q, so that's 3. Okay, so I don't really care about the details, but what I care about is looking at the pattern there. So just if we go back to everything we've done with these examples so far, so I'm just going to name them a special way. So I'm going to see there's Q perfect competition. So that's equal to, we've seen it's equal to 12, and the price was 1. All right, so Q perfect competition is 12, and price perfect competition equals 1. And now let's see if you have this situation there. I have that Q, I'm going to call this Q, yeah, so let's call it already Q and price oligopoly. And yeah, here I had, so here that was for duopoly. So let's call it duopoly and price duopoly. Here, let's call it Q perfect competition. Perfect competition. Yeah, so that's mono. And human. So now we can compare all of them. So let's have Q early, which is equal to 3, and early, which was equal to oh no, Q is 10. Sorry. Okay. Next one, duopoly. Q duo was 8 and price duo was 5. So duopoly we had 8 and 5. And all the way to the end, single firm on the market, we have mono, which was, I believe, 6, and mono, which was more. Just to verify, had 6 and 7. Yeah. Okay, so what's the pattern there? So now I let you look at all these things that we did so far. So here I have perfect competition. I have a very, very large number of firms. Here I have 5. Here I have 2. Here I have 1. Yes? Yes. And what about the price? Yes. So more firms on the market means higher production and lower price. Stronger competition. Firms. So each firm is unable to charge all that much for more than the marginal product for their product if they have more competition, because they have a smaller and smaller and smaller segment of the market to work with. If they are a monopoly and they have the whole market, then they're able to restrict production a lot and hike the price a lot. If they are just one of 5 firms, then they compete quite a lot between them, and things are not easy. By the way, that's a good. I had read this thing about car salesmen in the US. And so you always think if you go to some place to buy a car that they pressure you a lot and they want you to buy the car and they're ripping you off. But that's not the, well, it's true that they're trying to rip you off as much as they can, but the thing is they don't make a big profit out of it. They have a super slim margin because the competition to sell car is so high that for them it's they are just on the brink of bankruptcy all the time, and that's what happened in a healthy market where there is a lot of competition. And the opposite is a market in which you have very little competition, and then firms, one or two firms are able to extract a lot of profit out of the market. Yeah, so I think I should be done with this. So questions about oligopoly? No, so you see that the neat thing about Cournot is, so it's a very simple model. In real life, you would think, okay, maybe I can change the price to compete better against my competitors. Who knows? In reality, it's more complicated than just Cournot. And we're going to see that monopolistic competition is more realistic than that. But still, it's very neat because it's sort of a all-encompassing model that shows what can happen at the extreme when you have a very, very large number of firms, and at the other extreme when you have a single firm. So it's a nice nice summary of everything that's going on. So now let's go back to our to the where were we? Yeah, okay. So that was a brief review of monopoly. Well, actually, we didn't do a brief review. We studied what monopoly was. But so essentially, everything that they're saying is what we have just seen last class. So the marginal revenue lies below the demand curve. So you can see it here. So if you remember the graph we seen last time, so this is the demand curve and the marginal revenue is below it, because each time I increase my production, then I have to lower my price. So my marginal revenue is not the same as the price. Yeah. So the marginal revenue is always less than the price. So because smaller than 1, smaller than 0. So I have to decrease my price if I want to increase my production. The relationship between the marginal revenue and the price depends on two things: how much output the firm is already selling. So that's because if I reduce my price, I'm reducing my price on all the units I'm already selling. So, and the slope of the demand curve. So how much do I have to reduce my price in order to sell more? Tells us how much the market has to cut its price to sell one more unit of it. So essentially, the steeper the demand curve is going to be, so the steeper the marginal revenue is going to be too. So assume that the demand curve is like this. So this is what we have done before. It's just now they put letters there, but we have done that with price with numbers. is a straight line, then the marginal revenue that the firm faces is given by, yeah, it's not too clear. So, all right, so where does that come from? So you have to know. So yeah, so that's something I don't like about these slides is they sometimes they skip steps. So let's show it. Right. So we have Q equals A minus B times Q. So that's the demand. And now what we want to express is the inverse demand. So the inverse demand is I want to express P as function of Q rather than Q as function of P. So what I'm going to get is, so P times P equals A minus Q. And so P is going to be equal to A divided by B minus Q divided by P. So that's the inverse. And then the revenue is R equals to, I could write P of Q here, so that it's function of price. Price is a function of times Q. So this is what we've seen. So that's yeah. So that's just what we had here. And then the marginal revenue is equal to the derivative of this. So it's equal to A over B minus Q over B. If I take the derivative with respect to Q, and then minus 1 over B, but times Q, so minus Q over B again. And it's also equal to then what they do here is, oh yeah, there's a minus sign there. And what they do show is simply that they use the fact that A over B minus Q over B is the price. So it's yeah, they use a capital. Okay, so this is where it comes from. If you, so even when I saw that, I was like, what is it? Well, no, you have to just do the steps. If you do the steps, you see where it is. So the marginal revenue is the price minus Q over B. This is what you would get in perfect competition. So you would just get but this is the yeah, how I would say that. So effect of Q and P. So that's for monopolies. Yeah. All right. So that's the revenue side. Now so I'm guessing you're not entirely still perfectly familiar or comfortable with these things. All I can tell you is we're going to do a bit more later. So it's going to look again the same, but yes, yes. If you had done a few other classes in economics, you would be familiar with them. So yeah. All right. So another thing is average and marginal costs. So they are extremely important for market structure. Why? Because why do we get monopolists? We often get monopolists in cases where it's always cheaper or better or more efficient to have a very, very large. This naturally gets to a monopolist because if some firm in the market becomes large, then they just can crush competition and take over the whole thing. And so we get all these competitors to close down their firm. Yeah, so essentially the shape of the costs dictate what you're going to get. And if on the other hand, you get cost structure such as you get marginal costs that go very, very high. So think of if we're all shoemakers, we all make shoes at home with our little shoe machine. Then at some point, if I work 8 hours a day doing making my shoes, I'm happy. But then if I want to produce more and I produce 10, at some point I'm going to not sleep enough. So I have a very steep marginal cost to produce more shoes. So I'm restricted by it. So old technology where there's a higher marginal cost leads to perfect competition. Modern technologies where you can produce a very large volume, such that as a gigafactory for Elon Musk, then this tends to lead to very large firms, oligopolies, and even monopolies. All right. Yeah, and so we're going to, so we see costs in two instances. So average cost and marginal cost. And marginal cost, we know, is the amount it costs the firm to produce one extra unit. And what the average cost is the total cost divided by the output of the firm. Yeah, so when the average costs decline in output, then marginal cost is always less than the average cost. Yeah, so I'm going to show this in the next slide. And what happens if the average cost always declines? Then it means it's always, so that's large from high fixed cost. Variable cost. So in the example I'm going to give you, it's the example is something like creating apps for your iPhone, for instance, or your Android phone. I don't want to single out some firm in particular, but so what do you do when you create an app? Well, you spend a month writing the app or a year and making it very good. Once it's there, you put it on the App Store, and then there's no variable cost. If a single person buys it, or if 1,000 people buy it, it's the same. So what happens to average cost? Well, the average cost per app sold is lower and lower and lower if you have more and more and more customers. So if you sell 1 million copies of apps, then it's the cost of coding the app divided by 1 million. So it's very small. But if you just sell 10, then it's the cost of coding the app divided by 10. So it's high. So this is what they mean by average cost decline in output. It's if you sell more and more and the average cost always declines. So yeah. Example. So software. Software is a good example because they have very little variable cost. And here they give you this cost structure there, which is what you're going to get. So you have a big fixed cost F and a small variable cost, C times Q. But more importantly, it's a constant times Q. So it's the marginal cost is never going to increase. It's always going to, the variable cost is always a linear function of the production. And you see that what you get in terms of average cost, well, it's just C divided by Q. So average cost is C divided by Q. So it's F divided by Q plus C times Q divided by Q. So it's just F divided by Q plus C. And so what do you get? Actually, yeah, we did discuss that last time, if I remember correctly. So in a nutshell, what you get is the average cost. So this type of cost to what we call natural monopolies. So natural meaning it's a monopoly that emerges just because of their cost. So something like software is one, Hydro-Quebec is one, telephone companies. So all of these things where they have a huge fixed cost that they want to. So in the example I'm going to give you, I just have C equals 0. So no variable cost, just a fixed cost that you divide by the number of customers. Yeah, and this is what it looks like. Oh, so yeah, here they chose 1. So they chose C equals 1, essentially. So what happens to the, so this is, marginal cost is always 1, because 1 extra unit always costs me 1 to produce. What happens to the average cost? Well, if I just produce 1 unit, then it's super, super high. But then I produce 2, 3, 4, 5, 6, and I'm able to divide my fixed costs with over a very large number of units. So higher. And now we can get to oligopoly and monopolistic competition. So oligopoly is not monopolistic competition. So it's not it's close. Oligo. So internal economies generate an oligopoly market structure. So internal economies is when is exactly this. It's when the more you produce, the lower your average cost. This leads to very large firms. And the oligopoly, as we have seen, is there are several firms, each of which is large enough to affect the price, but none with an uncontested monopoly. So they have to live with their competitors. They cannot change them. Yeah, and also the yeah, and so they have strategic interactions among an oligopolist because each firm decides its own action, taking into account that decision might influence its rivals' action. So I know that in the yeah. So it depends on which model you look at. In Cournot's case, each firm essentially assumes that they cannot influence their rivals. But we have other models in which, yes, one firm can influence their rivals' action. So if you want to know the name, it's Stackelberg. Have you heard of Stackelberg in the past? Yes, so Stackelberg is one case in which the firm is going to just produce more, knowing that the rival are going to produce less. But here we don't really do that. In the case of Cournot, it's just yeah. So that's oligopoly. But now let's get to, at the end, monopolistic competition. So I wouldn't say it's a special case of oligopoly. I would say it's a sort of hybrid between oligopoly and monopoly. So what's different between monopolistic competition and what we've seen so far is, in case of monopolistic competition, then usually you get firms that have their own brand. So yeah. So you don't have the same product being sold by everybody. Now everybody is trying to convince you as much as they can that their product is just so different and so amazing and so better than the competition. So they are a monopoly, but with their own brand. The problem is that their own brand is not very different from the others. So if you buy a shampoo from Fructis, I don't know what, and you buy a shampoo from some other brand, at the end of the day, you can wash your hair and maybe you're going to see it's just so much better one to the other. But if you didn't have your Fructis anymore, you wouldn't die. You just buy some other brand and it's not the end of the world. Yeah, so, oh yeah, so it's written there. So each firm is assumed to be able to differentiate its product from its rival. But the problem is, yeah, so is assumed to take the price charged by its rival as given. So that's, yeah. So the problem for them, though, is that since, yeah, so that has many firms. Just that many firms can enter the market. So great number. Very similar. example. So that's any consumption good you can think of. So coin, cereals, bread, cars, computers. Computers it can get tricky because you can get locked in some system. Like if you buy something Apple, then it makes sense to buy everything Apple. So, but at the end of the day, you can just use them to compute stuff. So they're not all that different. Restaurants, almost, and advertising. And so how do you see this very elastic demand function? So you see this way. So what does that mean? It means, so I'm a monopolist, but in a market where there's just so many other markets that do the same. So it's not like my clients are forced to buy whatever I want to buy. So my demand might look like this. Very, very elastic. Because as soon as I try to increase a bit my price, then nobody wants to buy anymore. Well, it's maybe Fructis is able to increase a bit their price, but not all that much. So you get, so that would be the, and that would be marginal. So you see that the marginal revenue is still very, very elastic or very horizontal. So you don't have a lot of margin. So that's all I'm going to draw about this, is just to show you that if you have a very elastic demand, you get a also marginal revenue that is almost horizontal. So you're close to perfect competition in some ways. It's not all that far. Are there monopolistically competitive industries in the world? Some industries. So this I don't know why they they write this, because in my opinion, yes. So most of what we can buy as consumers are sort of brands that operate in a monopolistically competitive market. Here they say automobile industry in Europe. Well, in the US too, they have quite a lot of competition with different models that look a bit like the other. So, yeah, in my opinion, actually a monopolistic competition model is the most realistic of the one we've seen so far. Well, they're entitled to their opinion, I guess. Okay. So assumptions of the model. So now we're going to introduce more, again, the computation behind the monopolistic competition. So imagine an industry consisting of a number of firms producing differentiated product. So we expect a firm to sell more the larger the total demand for its industry product and the higher prices charged by its rivals. So why? Well, higher the total demand, so because of there are, of course, customers. And higher the prices charged by its rivals. Why? Well, because if rivals charge a higher price, then more consumers will want to buy your product. So um, and this is just the flip side, the side of this. So if there are too many firms on the market, then each firm is unable to sell all that much because they have many rivals. And if a firm charges a high price, then of course they are able to sell less. Yeah, another way of saying that is so this is what we've seen in the small example we've done with Kourno and Monopoly and the Perfect Competition. So the more firms on the market, the lower the market price because they compete harder for sliver of the market. So, elastic. So this is how they summarize this relation. So this is it. It's an important equation. So Q is the firm's sales, which is a function of S, the total sale in the industry. And the key point here is this is exogenous. So S doesn't change with it doesn't matter. It doesn't matter how many firms there are, what their price is. S is exogenous. Losing. Okay. Because I realized I forgot my adapter at home, and now I'm almost out of power. So when my computer dies, then we can take a break and we're going to switch to that. Okay. Yeah. So and then so Q is the sales price from sales. S is the total sales in the industry. S is exogenous. N is the total number of firms in the industry. So of course, the more the larger N, then the smaller each firm is able to sell. B is a constant term representing the responsiveness of a firm's sell to its price. So if B is the demand, so it implies that products are very similar. Right, so how do we, and then I'm just going to finish and then go back to, and then P is the price charged by the firm itself, and P bar is the average price by its competitors. So you see that if P increases, so it's going to decrease the number of, the amount of sales that the firm can sell. And if P decreases, then there's a minus, is going to increase. And going back to B here, what that means is, so the amount of responsiveness to the firm's price what does that mean? It means that, so if, take for instance, a case where you would really sell two products that are exactly the same. So yeah, Naya water and, or let's say Coca-Cola and Pepsi. Then Pepsi increases its price, then all its customers would go away because essentially there's no difference between Coca-Cola and Pepsi, so it would all go away. But then if you think about, I don't know, PC and Apple, then for Apple, then perhaps even if they increase their price to 1,000, 2,000, 3,000, 4,000, very high prices, still the people who want to buy their product love them so much that they are ready to pay such high price. So for Apple, yeah, so for Coca-Cola, Pepsi, products are very similar. And for Apple, versus PC, we would not, because products are not very similar. In my opinion, they are, but it's true that personally, I'm not used to using a Mac, and the keyboard is a bit different, and so I could get used to it if I didn't have a PC computer. But all in all, even if PCs are like 10% more expensive, I'll still buy one because that's what I'm used to using. Right. So this is sort of a demand equation for the firm, and it's a very important relation that's going to drive most of what we're going to see later. And then we are going to use this this concept we introduced just at the beginning of the class, symmetry. So all the firms are exactly the same. So this is one firm, Q equals, but you see that all the firms have the same B, and essentially so if they act in a similar way, then they are going to get a similar demand. So the result of that is that they are all going to be the same. So they are all going to have the same price. So if they have all the same price, then what's going to be their sales? Q. Just going to write the question there. Are the same. Their sales holiday. Oh, this is a good. Well, this is the average price in the industry, and this is the price of a farm. So if they are all the same, they sell at the same price. So P minus P bar is 0. So then this doesn't matter. And what we get is that 2 equals S divided by. So that's what they say. But I don't want to put that there because anyways, that's what they say in the next slide. Um, yeah, we've seen a lot already. So why don't we take a small break there? And I'm going to change my computer and make sure that this does not crash on me. And because I know that it's a lot of computation, lots of theory. It's getting that's coming, so I want to